Okay, lesson 1.2 is on radical operations. We're going to do it in 2 days. It's a little bit more difficult than last day, but it's going to be another short video, so that's good. So what we're going to be talking about is radical expressions, and radical expressions are any expression that has a radical sign in it. So we'll talk about what a radical sign is in a second, and I'm sure you already know. So let's take a look at this expression right here. This is a radical expression. This is m times the nth root of a. That's how we say that. So what are all these things? This m, this n, these a. We learned this last year, but you probably might not remember. M is called the coefficient. That's what you're multiplying. You're multiplying whatever this amount is, m, by all of that. So if there's a 5 there, it'd be 5 times all of that. The n, that's the index. If it was a 2, it'd be a square root. If it was a 3, it's a cube root. If it was a 4, it's a fourth root. Right? A is called the radicand. The number inside this sign is called the radicand, and the sign itself is called the radical sign. So a radical expression is any expression that has that sign in it. Alright, some more review from last year. If you have an exponent that's a fraction, like in all these three cases here, you have a fractional exponent. As soon as you see that there's a fraction that's exponent, you can draw a radical sign. You know there's going to be a radical sign in as another way of expressing this. So, do you remember how to do this? The base, which in this case is 8, goes inside the radical sign. The number on the bottom here, the denominator, remember we kind of thought of this as being underground, and what's underground are roots. So that's what root it is. It's the third root of 8, or the cube root of 8. So the 3 comes out front. And the 1, you could either put it right here, like that, or you could put it like that, raise the whole thing to first power. But if you think of it, the first power doesn't really make a difference. So let's not even worry about the numerators today, because they're all 1, and it doesn't really impact anything. Next day we'll worry about numerators other than 1. Okay, the cube root of 8. So you should know what this is equal to. The cube root of 8 does not mean 8 divided by 3. It means what's a number that when you multiply by itself 3 times you get 8? And the answer is 2. And why is it 2? Because 2 times 2 times 2 equals 8. That's why the cube root of 8 is 2, because it takes 3 2's multiplied together to get 8. Okay, I'm going to erase that part. Next one, 9 to the 1/2. There's a fractional exponent, so we know we're putting a radical sign. The base goes in the radical sign. The number, the denominator goes out front. Or not, right? If it's a 2, you don't have to. You don't have to put the square root. I will write it in this case, but it'll probably be the last time I do this here. And then it'll be all to the first power, but we won't bother doing that. Okay, it does not mean 9 divided by 2. It means what number multiplies by itself 2 times to get 9? And the answer is 3. Why? Because 3 times 3 equals 9. It takes 2 3's multiplied together to get 9. Last one here, a to the 1 over n power. Well, there's a fractional exponent, so we're going to put a radical sign. The base, which is a, goes inside. The denominator becomes your index, and you raise it all to the first power, but we won't bother doing that. And we can't do the next step here because we don't know what the nth root of a is. There's no numbers, so it doesn't really help us. Okay, now what I want you to do is to look at, there's another way of writing this. So I just want you to look at the blue bits here. You can forget about this these first expressions here. If the cube root of 8 equals 2, another way of saying that, you remember I actually wrote this. I wrote 2 times 2 times 2 equals 8. Or a faster way of writing that is 2 cubed equals 8, right? I had shown you before that the reason the cube root of 8 is 2 is because 2 times 2 times 2 equals 8. And all I'm saying is that's the same as 2 cubed equals 8. Alright, how can we rewrite this? If the square root of 9 equals 3, then 3 squared equals 9. You see we're taking this, raising it to that power to get that answer. 3 squared equals 9. Okay, how about this one? We can't do it because there's no equals here. Well, let's make this amount, whatever this amount is equal to, let's make it equal to x. Okay, we'll just call it x. If that's the case, how can we rewrite this then? Well, if you follow the pattern, 2 cubed equals 8, 3 squared equals 9, it would be x to the nth power equals a. Okay, and this is what we're going to focus on for the rest of today's lesson. We're going to look at 4 different possibilities for this case right here. The first case is when a, this number or whatever, this number right here, when a is positive, and when n, the exponent right here, when n is even. So an example of that would be something like x squared equals 25, right? Our n value is 2, and that's an even number. Our a value is 25, and that's a positive number. Now, if you were going to solve this, you could just think about what the answer is, or you could do it algebraically by thinking to yourself, I want to get the x by itself, and right now it's x squared. So I'm going to do the opposite of squaring. What's the opposite of squaring? Square root. So we take the square root of both sides. If you take the square root of x squared, you're left with x. And we take the square root of this. Now, you have to be careful. A lot of people do that, that's great, and then they say, well, I know what the square root of 25 is, square root of 25 is 5, and I'm done. But you actually have missed an answer. When you're solving equations and you have to take the square root, or the 4th root, or the 6th root, whenever it's even, you need to put plus minus. Why? Well, first of all, let's just say that the plus minus carries along here, so you end up with the answer x equals plus or minus 5. So why do you have to do that? Well, let's think of this. If what we're looking for in the original question is a number that multiplies by itself to get 25, definitely 5 works. 5 squared is the same as 5 times 5, and that does equal 25. But negative 5 also works. If I square negative 5, I get negative 5 times negative 5, and that equals positive 25. So you need to take both of them into account. If n is even, if this exponent is even, you have to put plus minus. Now, don't get confused. If I just asked you to evaluate this expression, if I said, how much does this equal? The answer is 5. It doesn't equal plus or minus 5. What's the difference between this and this? This is an equation. I'm asking you, what could x equal such that when you square it, you get 25? And in that case, there's 2 answers, 5 and negative 5. If I just have this written, square root of 25, then by convention, we just take the positive one. Okay, if it said this, then the answer would be negative 5. If it said this, then the answer would be plus or minus 5. But if you're solving an equation like this, you always have to make it plus or minus. That's often forgotten by students. Okay, let's just do one more of these. What if you had x to the 4th equals 16? Well, you'd want to do the opposite of raising something to the 4th power, which is to take the 4th root. If you took the 4th root of this, you'd just be left with x. If you took the 4th root of 16 on this side, you're looking for a number that multiplies by itself 4 times to get 16. You know what it is? It's 2. But again, this was an even exponent, so you need to have plus minus. You need to have plus minus. If you're not sure why that is, because you could have 2 times 2 times 2 times 2, which is the same as 2 to the 4th, equals 16, or you could have negative 2 to the 4th, because negative 2 times negative 2 times negative 2 times negative 2 also equals positive 16. Those two negatives make a positive, those two negatives make a positive and the positive equal positive. Okay, so the take-home message here is there will be 2 nth roots. In this case, they're 2 square roots. In this case, it's 2 4th roots. If it was x to the 6, it'd be 2 6 roots. Alright, possibility number 2, a is negative and n is even. So an example of this would be something like x squared equals negative 25. So remember, a was this number, and yes, we've made it negative, and n is that number, and we've made it even, in this case 2. Okay, so just like up here, the way we'd solve it is we'd take the square root of both sides, so the square root of negative 25, and before I put plus minus here, I'm not going to bother. How come? Square root of negative 25. What do you say about that? I say, no way, no solution. Okay, you can just put this symbol right there, no solution. Don't put 0, that would mean the answer is 0. The answer is not 0, the answer is no solution. Why is there no solution? Because if you multiply, some people think the answer is positive 5. No, positive 5 times positive 5 is positive 25. Some people think the answer is negative 5. Negative 5 times negative 5 equals positive 25. That didn't work either. And some people think the answer is 5 times negative 5. But that doesn't work either, because if it's you're looking for a number you square, and this isn't squaring, that's two different numbers. None of that works. So if you have this situation, then there's no real solutions. I have to put real because if you take mathematics in university, you'll learn about imaginary numbers, and imaginary numbers would work. You would end up with the answer 5i. That's right, 5i. Okay, the third case, if n is odd and a is positive or negative, it doesn't matter what a is. So the important part is that n is odd. So that'd be something like x cubed equals 27. Okay, so since this is x cubed, we're going to do the opposite of cubing, which is take the cube root. If you took the cube root of this side, you'd be just left with x. If you took the cube root of this side, first of all, should we put plus minus here? No, you should not. Why not? Well, let's think about this for a second. What's the cube root of 27? That's a number that multiplies by itself 3 times to get 27. The answer is 3. 3 times 3 times 3 equals 27. Like, why do you not put plus or minus here? Because if you did, it would mean that 3 times 3 times 3 has to equal 27. And it does, so that's perfect. But it would mean negative 3 times negative 3 times negative 3 would also have to equal 27. And it doesn't. It equals negative 27. So do not put plus minus when it is an odd exponent. Only when it's an even one, like up here. Just to write it down, I already kind of talked about it. If it was x cubed equals negative 27, then you would take the cube root of both sides. This would equal x. Take the cube root of negative 27. Now, don't get fooled. Remember up here, you couldn't have a negative inside a radical sign. That's only when it's an even index. Right? There's a little 2 here, isn't there? Then you can't do it. If it was a 4 here, you couldn't do it. If there's a 6 here, you couldn't do it. But if there's a 3 here, an odd number, no problem. You can do that. X equals negative 3. How come? Because negative 3 times negative 3 times negative 3 equals negative 27. Now, if you're getting overwhelmed with these rules and everything, I don't want you to really have to memorize the rules. I just want you to understand about radical signs and what they mean and everything, and the rules should kind of take care of themselves. It's more important that you understand all this about what a radical sign means, and that 2 negatives make a positive and all that. It all makes sense if you understand that. By the way, let's do one last example here. What if it was something like x to the 5th equals negative 7? Okay, to solve this, I'd take the 5th root of both sides. So that'd leave me with x here, and I'd be left with the 5th root of negative 7 over here. Okay, first of all, can I do that? Can I take the 5th root of negative 7? Yes, I can, because this is an odd index. If this was a 4 or a 6 or a 12 or a 20 or some other even number, there'd be no solution. But there is a solution here, because this is odd. So what's the solution? I have no idea. I do not know what the 5th root of negative 7 is. It's probably something like negative 1.1 or something, but I don't know what it is. So you just stop here. You don't take the next step. Why is this solution? Because, I know this is crazy, but because the 5th root of negative 7 times the 5th root of negative 7 times the 5th root of negative 7 times the 5th root of negative 7 times, how many times am I going to do this? 5. I'm looking for a number that works when you multiply it together 5 times. If I took the 5th root of negative 7 and multiplied by itself 5 times, like I did here, what would I get? I'd get negative 7. Okay. So, to summarize that, if you have this situation, you'll end up with just one root, one nth root, one cube root in this case, and the cube root's 3, one cube root here, and the cube root is negative 3, one 5th root here, and the 5th root is the 5th root of negative 7. Okay, the last situation is a pretty simple one, when a is 0. So an example of that would be something like x to the 9th power equals 0. If it's raised to the 9th power, to solve this algebraically, we take the 9th root of both sides. That leaves us with just x here, and the 9th root of 0. So what's that mean? It means you want a number that you can multiply by itself 9 times to get 0. What number multiplies by itself 9 times to get 0? 0. 0 times 0 times 0 times 0 times 0 times 0 equals 0. And it doesn't matter what the exponent is. If you put x to the 20th power equals 0, you're going to take the 20th root of both sides and you're going to get 0. So to summarize this one, the answer is always going to be 0. So there's just going to be one root and it's always going to be 0. Okay, hopefully that makes sense. Next day we'll get into the really hard stuff. In fact, some people claim it's their least favorite section in the whole course. So I hope you've enjoyed these two easier sections, shorter videos. We got a doozy coming up next class. But I do have good news. It's really not that important in the course. Okay, it's kind of like almost a bonus topic. Alright, take care.
I feel so alone, gonna end up a big